Hello. Today I'm going to be covering the new loot table system coming in the Inventory Framework plugin. This is a new abstract loot table system that tries to be, as the name implies, as abstract as possible. So to begin, let's cover some of the key points. Here are the design parameters that the loot table system tries to follow. It is handled through a actor component and instance objects. This means you can create custom loot table systems and even mix multiple types of loot tables. And it's supposed to be usable everywhere. So that includes any actor in the level. It is meant to be usable in the data asset. It is meant to be usable in the class defaults. So being able to just add a loot table through this and so forth. It's supposed to be accessible from essentially anywhere. We can see here, container settings, loot tables, it can be found here. The main purpose of loot tables is to be able to very easily add content to your game through either modular game features or through your own custom methods. Hence why everything is handled through instance objects, which I'll cover in a moment. There are two examples that will be included in the plugin. If we take a look at this chest that we have in front of us, we take a look at its loot table component, we can see loot pools. And these are the ones that are actually modifying the container settings items array. I would suggest going quickly over some of these points and so forth. This video will be mostly covering the actual codes. So to begin, we can see here we have a simple loot pool object that is adding a backpack, has 100% spawn chance, and is only adding one. Here we have a note, so forth and so forth. But then we have this tag pool, and the tag pool requires a bit more explanation because it's a lot more complex. This is the advanced example. This loot pool object has the ability to be globally modified during runtime through modular game features. This system utilizes a world subsystem that only exists on the server, and modular game features can dynamically add and remove items from this subsystem. The subsystem has a map of tags, and this object fetches the items to use through this tag. So if we take a look at the source code, we look at the subsystem, which can be found in the new folder under just public loot table system. And here we can find the subsystem and the game feature action that I'll be covering in a moment. And you can see here is the T map, and it is just gameplay tags, and then the struct, which is just an array of another struct, which looks very similar to the simple loot table. The simple loot pool, I mean. But this one is using a soft reference. So if we take a look at this modular game feature, by the way, if you are unsure of what a game feature is, I would suggest looking up these three videos. This video is quite good. It covers what it is quite well. And then this is more technical details. And what they essentially are is that it's a plugin that you can activate and deactivate during runtime. So you can add components to actors and so forth and so forth. And in this example, we are getting a tag loot pool that has the tag IFP interactable chest, and we are adding these two items to that pool. So if we take a look here, we can see this tag pool is using this tag. So if we now come here, we can see the apple got added. we can see items are randomizing quite frequently. And even the random min-max count is also randomizing. A cool thing about the subsystem is we can register it and activate it during runtime. So we can unregister this, take a look here. None of these items can be found. We can then activate this and go to another chest that has the same tag loot pool, and now the items can be found here. This also means you can just do this during runtime. So I can go here, I can press R, and now the helmets can be found in the chests. So if you ever want to gain access to this tag loot pool storage, you just go here, get tag loot pool storage, and you'll get the subsystem. And you have a few functions from here. Tag loot pool, add item, append, so you can have your own loot pool map, get items, remove, and so forth and so forth. You can even just ask, what is the spawn chance of an apple, and so forth, without loading the asset. For a simple example of how the loot tables work and how they're initialized and so forth, when the component is being initialized, it first tries to find any items that have the tag ifp.initialize.include loot tables. So for example, if we wanted this gun to include its loot tables, we just add that tag. And now when we loaded the game, this site is automatically added to it because we have defined a loot table in the data asset in here, as you can see. It then keeps on going through all the loot tables, and the loot tables can also be recursive. So if you call this function add item and you check include loot table, that means you can get recursive loot tables. So a backpack can spawn a gun, and that gun can include its loot tables, and go on and on and on and on. So for the simple example, we just shuffle the pool that we have assigned. We try to find out if the parent item that owns this loot table, for example, does this belong to a backpack or not? If so, then use those containers. If not, then use the default container settings in the inventory. And later we will be using this to find compatible loot table, compatible containers for the item. So we don't accidentally put the item into a container that it is not compatible with. Then I just do a for loop over the items, do a random bool with weights, just create a simple struct, assign the item assets, assign a random tile index, and then a random min-max count. Then make sure we find any containers that it's compatible with, and then just do random and try to add the item there. And then I just increment the amount of items that have been spawned, because some loot tables have systems where you might want to only have 10 items max spawn, or you might want to exponentially decrease the amount of items more and more the more items that are added, or create some kind of min-max amount of items that must spawn. And the tag pool is very similar. It's doing very similar things. It's getting the items from this specific tag. It's shuffling that. Then basically doing the same thing. It's then loading the asset. There is a function called preload assets. So if you were to somehow detect that the player is getting close to the chest, you could call this function on the loot table component, I believe. Yeah, you can just call preload assets, and that will call preload assets on all the pools. I am not doing that in this example because I'm trying to keep things as simple as possible, and there is currently no way in the example project to detect if the player is close enough to the loot pool or to the loot table. So hence why I'm just using load asset blocking and then casting. And then it's the same deal, getting a compatible container, adding it, incrementing. And that is the general gist of a simple loot pool system. But in general, lots of people have very different opinions of what a loot table is supposed to be and how it's supposed to be structured and so forth. Hence why it is so abstract, where you have full control through these loot pools. Throughout my research, there were a lot of different ways to do loot tables, and I thought this was probably the best approach to just do it in an abstract way so everybody can implement their own versions. For a quick idea on how to add the loot tables to your own item assets, so let's say you have made your own custom item asset, or maybe you want to add loot tables to, I don't know, the item attachment. I know some people have been adding containers to this. We can take a look at the equipable as an example. You will basically just want to copy this. Just make sure it's instanced. It is the UAC loot tables. You will then want to overwrite the get loot tables function and just return that variable. That's all you really have to do. Thank you for watching. Hope to see you in the next one. Bye-bye.